Hello Math 8 students, this is Open Up Resources Unit 2 Lesson 8 on similar triangles. To understand this lesson and the point of this lesson, you first need to make sure that you understand Lesson 7. So to get started, we are going to start with this in a second, but I really want you to take a second and review what are the big takeaways from Lesson 7. Specifically, how do we show that polygons are similar? Pause the video to give yourself enough think time or to go and look up the answer in the summary from Lesson 7, but I do want you to answer this question before you go on. The big takeaways from Lesson 7 are that when we have two polygons that are similar, every angle and side in one polygon has a corresponding part in the other polygon. That seems pretty obvious and intuitive, but it's important because the pairs of corresponding angles have the same measure. So when we're looking at two polygons and trying to decide if they are similar, like these polygons down below, we can see these are not even the same angles. There's no need to go on. These are obviously not similar. The other thing is once we do see that we have the same angles, as in these two rectangles here, then we want to check something else out, and that is that corresponding sides are related by a single scale factor. That means each length in one figure is multiplied by the scale factor to get the corresponding length in the other figure. For example, that 2 is multiplied by 1.5 in order to get the 3. And if these were similar, I could take the 3 and multiply it by the same scale factor 1.5 to get this number here. Unfortunately, 3 times 1.5 is not 4 because here we would have to multiply by 1.3 overbar, or 1.3 repeating, which means since I'm using different scale factors, that means that these are not similar polygons. Those are the biggest takeaways. Really, truly, we can summarize by saying we need to check the angles and we need to check the side lengths. Specifically, the side lengths need to be related by a single scale factor. With that in mind, we are ready to start Lesson 8, and we start with this little warm-up, equivalent expressions. You need to create 3 different expressions that are each equal to 20. Each expression should include only the numbers 4, -2, and 10. And yes, you need to use the numbers 4, -2, and 10. You have to use all 3, and you can only use those 3. Some clues: you need to connect these numbers 4, -2, and 10 using things like division, multiplication, subtraction, addition. Use operations in order to combine these in such a way that they get to 20. Do that creating 3 different expressions. Pause the video until you've gotten that done. Here are some examples that students in class came up with. They said 4 plus a -2 is going to give us 2. And 2 multiplied by 10 is 20. But I do need to put this in parentheses since that needs to happen first before I try and multiply it by 10. Again, 4 plus -2 is 2. 2 times 10 is 20. So this expression does equal to 20. Other examples would include different variations of this. So of course, if you decide to use commutative property of addition and multiplication and change the order, that would also equal to 20. But if you want to get really creative, you could have also come up with things like this. 4 divided by -2. Well, that's going to be -2. -2 times 10 is -20, and that's not really what I'm after. I need it to be a positive 20. So since this is -2, I can take all of that inside the parentheses, turn it to its opposite, and then multiply it by 10. So just some other ways that we can look at this. Again, that expression would end up equaling out to being 20. Now let's dive into our lesson. What we're going to be doing is in class, we made triangles using pasta noodles. For you online learners, that's going to look a little bit different, so I'm going to switch gears. We're going to take a look at Canvas. In Canvas, I have prepared a PowerPoint document so that you can do the same type of activity. You're just going to be doing it digitally. Instead of trying to hunt in your house for some pasta noodles, we'll go ahead and do this digitally. Just like we've done in the past, this is going to create a read-only document, so you'll have to save it to your own drive in order to be able to edit it. To model that, I'm going to be going incognito. You just need to click on the link. Going incognito opens this up, or for you, clicking on the link, it will remind you it's read-only. So the first thing we have to do is File, Download. We are downloading a copy. Don't click any of these other options because it will make it so that it's non-editable. We want a copy so that we can edit it. It's going to let us know that it's ready to download. Here's my download, Max. Yours is going to show up in the corner here. Open that up, and now I've got this beautiful PowerPoint that I do need to enable that editing, but I can begin this activity. Let's move on to the next slide. And the first thing that we're going to do, this is angle set number 1. I've given you 2 different angle sets. Here's angle set number 2. Focusing just on angle set number 1. These are your pastas. It's like your giant spaghetti noodles. And here's your 3 different angles. Using just angle A, so these other ones I can go ahead and move off to the side. We don't need them. Using just angle A, I want you to create a triangle. Obviously, you're going to be using some of these spaghetti noodles. So starting here with angle A, I'm obviously going to need a spaghetti noodle here, and I'm going to line that spaghetti noodle up with this pasta, with this angle. Imagine that these were actually pasta noodles. Pasta noodles break, so you can shorten it. Or perhaps you started out with a little bit longer pasta noodle. Maybe it was that long. So that's the idea. I'm going to need my second pasta noodle to finish forming this angle. And of course, it's not in line with that angle, so I'm going to line it up here. And maybe I broke this noodle and it's going to be really short. Now, this isn't a triangle yet. This is just forming that angle A. But now that we have this much done, we can easily use another pasta noodle to finish up that triangle. So lining that up here. This time I'm going to have to make my pasta noodle a little bit bigger, and that's the advantage that you guys have, is that you're not actually limited to the pasta noodle lengths. You can change the lengths of these fake pasta noodles here. So there's my triangle. I'm hoping that you were able to make your triangle look different. Don't make it look exactly like mine, but I just modeled how it's supposed to look. Now pause the video and you go onto your PowerPoint and you make your triangle using only angle A and a few pasta noodles. Okay, now let's move on to angle set number 2. Same thing. Using only angle A, make a triangle. So I'm going to move B and C out of the way. Notice that it's a different set of angles, right? But I'm just going to be using A. Making my triangle with some pasta noodles here. You can pause the video so you don't have to watch this, or you can skip ahead. I'm just modeling once again what you should be doing as you use angle set number 2 and create your triangle. Again, mine ended up a little bit longer, so I'd have to break that pasta noodle or shrink it on down, and there is my second triangle. And now, as we move on to the next slide, it says copy and paste both of your triangles here so that we can compare and measure. So I'm going to come over here, and I'm going to select these. Oh, that didn't work out. Here's what I'm going to do. I'm going to click on each one of these. So I am clicking and pressing Control. So Control on my keyboard is down as I click. Control is down as I click, and Control is down as I click. That selected all 3 of them. And now I'm going to try and group those together. Now that forms a triangle that I'm able to move around. So let me do that one more time. Since I thought I could just select them and they would all group together, it doesn't. So I have to click on this, then I press Control, click on the next piece of pasta, Control is still down, and I'm clicking on the next piece of pasta. That selected all 3 of those, and then I right-click, group together. Now I've got one triangle. And I'm going to copy that triangle, so that would be Control C, or right-click and copy. Going on over to this page where I'm going to Control V or right click and paste it. Okay, so there's my first triangle, and here is my second triangle. I'm going to repeat that. So I need to select each of these, grouping them together. And now I've got a triangle that I can copy and paste over here. And I've got these centimeters, and it's not exactly centimeters, but at least it's a measuring device. And I've got this protractor. So we can use that protractor to measure these angles. And to measure the side lengths in centimeters. As you're doing this, make note of the side lengths and make note of the angles. You should probably kind of jot it down, or you can be really technical here and we can insert a text box so that we can copy down that measurement. So this triangle here has a length of, it looks like I'm going to go and say 13.7 centimeters, maybe 13.8 centimeters. We'll say 13.7. And then I would need to take this and kind of rotate it so that I can measure the next piece. Gotta make these adjustments, make sure it's rotated just perfectly so that I can get a nice good measurement. And it looks like that. We can say 4.9, maybe we can say 5 exactly. I think I can say maybe even 5.1. So again, I'll insert my little text box here, type in that measurement, 5.1 centimeters, and so on. Continue that process until you have measurements for all 3 of your sides for each triangle. Then you will also need degree measurements for each one of the angles. The little caveat here is just measure to the nearest 5th degree. This one worked out very nicely. This is a 50-degree angle. So again, I don't want to forget that. That is a 50-degree angle. I don't know the shortcut for getting that degree symbol up here. So 50 degrees for that one right there. Going to have to rotate this to get into place, but what we're doing, we're measuring to the nearest 5th degree. Got that in place there. It's lined up, and it looks like this one. So again, this is what I'm talking about. This is a great example here. It's a little bit less than that 80 degrees there. But since I'm measuring to the nearest 5th degree, even though it's probably like 78-ish degrees, the nearest 5th degree, I'm still going to go ahead and put that it's 80 degrees because 78 degrees would round up to 80 degrees. So just take the time, measure each of your angles, measure the lengths of each of the sides, and do that for both triangles. Pause the video until you've had a chance to do that with your own triangles. Okay, I have completed the measurements for my triangles. I hope that you're continuing because you have also completed the measurements for your triangles. And now we're going to kind of return over to the task. We've completed everything that the students did in class with their pasta noodles. Now let's answer those questions. It says find one group in the room who have the same angle A and compare your triangles. Well, what we have done actually is we have created 2 triangles using that same angle A. So this would be like one group and this would be like the second group. So notice that they both have that same 50 degrees, and I can even, let me get the actual triangle. I can take it up and line it up just to prove that we use that same angle. Maybe you didn't recognize it at first, but it is that same angle. So we found the 2 groups with the same angle, meaning we created our 2 different triangles as if we were 2 different groups. And now compare the triangles. What is the same? What is different? Are the triangles congruent? Are they similar? How are you deciding if they're congruent or similar? So with those questions in mind, let's see. What's the same? Well, for sure, one thing that's the same is they both have that 50-degree angle. The other angles are definitely not the same, so that rules out right away that they're not similar because they don't have the same angles, so they're not similar. It also rules out congruence. If they don't have the same angles, then they also can't be congruent. Is there anything else that's the same? Looks like all of the side lengths are completely different. The only thing that they have in common is that they both have that same one single 50-degree angle. So that angle A is the same in both. It's 50 degrees. What's different? Everything else. The triangles are not similar or congruent. This is actually more impactful than you realize. That means that if I have just one angle of a triangle, it's not enough to show similarity or congruence. So what if I have all 3 angles? So this is our second activity, and it looks like I've already given away some answers here. Here is our second activity. Now we're going to repeat this again with angle set number 1 and angle set number 2. What we're going to be doing is creating another triangle. This time we're going to use all 3 angles, angle A, angle B, and angle C. So let's return to our PowerPoint. Now we're angle set number 1, activity 2. So this time we're using all 3 angles to make a triangle. Again, I will model it and then I want you to pause the video and do it on your own. So I'm going to start with angle A just like I did last time. Oops, here's my pasta noodle. I'm going to go ahead and get that into place. And again, if you want to start with a longer pasta noodle, you can. If you want to cut that pasta noodle down and shorten it up, you can also do that. So I'm going to start with some short pasta noodles this time and kind of get started kind of the same way that I did before. Before I get too far along, I need to, so this is kind of how I started my last one, but now we have to use these other angles. So I'm going to rotate this angle into place to get it to line up with that pasta noodle. Looks like I need to rotate it just a touch more. Maybe I went a little bit too much. And then I'm going to line it up there with the end of that pasta noodle. So it looks just like that. And now I also need to use this angle. So although I'm not totally completely done, maybe I'll take this and I'll turn this pasta noodle, get it into place. I'll keep it a little bit long for now. I know that this angle has to rotate into place there. Oops. Come on. That one has to rotate into place. I'm going to rotate it now and see if I can't get it to line up there. Things are going to be just a little bit off. This level of precision is a little bit hard to achieve here, but you can see that this pasta noodle is a little bit long. This one I probably shouldn't have cut so short, so I'm going to make that longer. Again, that's the advantage to you guys having an infinite supply of pasta noodles and being able to change that length. So here is that triangle that I have created. Now I know the size that it needs to be, so I can go ahead and cut that pasta noodle down again. So I modeled making your triangle using all A, B, and C. Try and make yours look a little bit different than mine. Maybe start with longer pasta noodles or something like that. So do try and make it look a little bit different than mine. Return to the video once you have made your own triangle. Now we're going to use the same angle set. Activity 2, use all 3 angles to make a second triangle. So again, let's pay attention to what that looks like. Here is that angle set number 1. Here's the same angle set number 1. So here was one triangle. Now I'm going to attempt a second triangle here. Okay, so angle A, angle B, angle C. I already know what I did last time. I had to kind of rotate these into place. So I'm going to start that rotation now. You can skip forward in this video a little bit if you would like to. You're just making your own triangle using angle set 1. It's just a second triangle, different from this one. So here is our first one. Here is our second one. Get that pasta noodle ready to go. Keeping these a little bit longer this time. Looks like that. It's almost ready to be lined up. Need another pasta noodle here. Changing the lengths of my pasta noodles. There we go. And this one needs to be just a touch longer. Okay, and there is my second triangle. When I move on to the next slide, it says take both of those triangles, those new triangles that we made, copy and paste them here so that we can measure and compare. So just like before, Control as I select each one of these so that I can right click and group them together. Now I've got that triangle copied over here. Same thing, taking these, Control and click so that I can group them together, copy it, and paste it over here. Let's get ready to measure and compare again, same as last time. Measure all side lengths to the nearest, measure all side lengths to centimeters, measure all of the angles to the nearest fifth degree. Pause the video until you've done that on your own triangles, and I will demonstrate here with my triangles. Okay, there's all of my measurements. Now it's time to compare. So you should also be done measuring your triangles, measuring all of the angles to the nearest fifth degree, and measuring your side lengths as well as you can. Let's compare. Find one group in the room who use the same angles. Well, we use the same angles each time. We're comparing our triangles. What is the same? What is different? Are the triangles congruent? Are they similar? When I'm looking at what's the same, I did forget a measurement. Let me pause and measure that measurement real quick. It looks like it is also 60 degrees there. Let me go back to my symbols, find my little shortcut here. That's how I got my degree symbol in there. There we go, 60 degrees. Okay, so now we're comparing what's the same. Looks like 50 degrees, 50 degrees, 70, 70, 60, 60. Even the triangles that you created, since we use the same angle set, they should have the same measurements. The side lengths might be different. So we have the same angles, the side lengths are different. We should probably write that down. What's the same? All angles are the same this time. Side lengths are different. Are the triangles congruent? No, since they have different side lengths, that would be not congruent, but are they similar? So again, let's go back to what we should have taken away from lesson 7. We need to check the angles. The angles actually match this time. So now we need to check that scale factor and see if it works every time. Now, as we're doing this, please understand there's going to be some measurement error. As precise as we try and be, there's still going to be some error there. So I'm taking a look here and I'm asking, okay, how does this 9.5 change to be a 15? I don't know. So I would work backwards. And when I work backwards, that means I'm dividing. So 15 centimeters divided by the 9.5 centimeters. I'm going to type that into my calculator here. Looks like 1.5789. So that means that to go forwards, the scale factor here is we're multiplying by I'm just going to say 1.6. Does it work here? Can I take that 8.5 and multiply by 1.6. Let's give it a try. And it looks like I got 13.6. I measured 13.5. It sounds like I actually did a pretty good job of measuring. I was just a little bit off, but I'm going to go ahead and say yes. Again, remember that our errors are not necessarily due to calculation, but due to some measurement issues. So I'm going to go ahead and say, yeah, that checks out. What about here? Can I take this 7.7 and multiply it by that same 1.6. Let's try it. 7.7 times 1.6, and I get 12.32, 12.4. So again, my measurements were pretty good, just a little bit off, but it's because we're trying to measure using some digital tools. So yeah, I would say that we are multiplying each one of these by the same number. That means they have the same scale factor, which means they are indeed similar. Yes, they are similar. And how did we decide if they were congruent or similar? Well, we went through that whole process. I'm not going to make you write it down, as long as you actually did the work. And now that's where we're going to end this video, because that's a lot of practice. That's a lot of work to do. We're going to end the video here, and we're going to continue this lesson tomorrow. I do want you to notice that in that PowerPoint, there are a few extra slides. If you want to continue this activity, you can do the exact same thing using angle set 2. Oops, went too far. Angle set 2, make a triangle using all 3. Make a second triangle using all 3, and then you can come down here and measure and compare again. It's not required, but it is optional, and I wanted to give you the option to really practice it and try it on your own. This final slide here, we're going to be saving that for our next video. So you've already downloaded the PowerPoint, you've already saved it, just save it somewhere safe again, so that in the next video you can pick up right in that same document and continue with us. That's it for today. Thanks for watching, and we'll see you next time.